Good morning all. The visual teaching for the lesson plan 3, we have prepared it and will present it in a group of 4 members. This visual teaching will be based on Year 12 Physics Chapter 5, that's current electricity, and the topic is resistance in series and parallel circuit. Before beginning with this class, I'll be telling you on how you'll be able to know about today's topic. So basically there's example of the highway roads. So when you go to the highway, you'll be starting from one point to the other. That's an example of series cell. And when you go along the road, you'll also see branches along your left side, right side, and if you have to go from one branch and then again come to highway and then go ahead and again have to go to another branch, that's an example of a parallel circuit. Moving on, electricity. So what is electricity about? Electricity is a common thing that is used in homes. This is the flow of electric power. It contains the electric power through which we are able to use the electric appliance. That is how we are able to charge everything. For example, charge a phone. That's where the electricity works. The lesson objectives for this topic is first to define series and parallel circuit. Second, draw the series and parallel circuits. And third one is to differentiate between series and parallel circuit. This is where you'll be able to know the differences, what are the main differences between the series and the parallel circuit, so that you'll be able to know what it all about. What are circuits? As you can see, they are A and B. There are two circuits, which is basically a series and parallel circuit. So first of all, before moving on to the types of circuit, first we have to know what is circuit. Circuit is the path. As you can see here, one path going like this path. These are the path between two or more. Two, or there can be more. Two or more, along which points the electric current can be carried. So circuits are through which the electric currents can flow. So there are two types of circuit. One is series and the other one is parallel. Series circuit. You can see these are the current flows from one direction to the other. There's no in between there's no branch in this. This is an example of series circuit. So when the current flows, it goes through this line, goes to the resistor, and it flows in one direction. This is the path along which the whole current flows through each component. One component is here, one component is here, one component is here. And parallel circuit, this is a closed circuit. Why we are calling this a closed circuit? Since when the current flows from the generator, it goes here, but you can see there's a branch going over here. Just like the main highway is like this, and the branch is going. So the electric current divides. It gets divided over here, and only when it goes like this, only part of the electric current goes through each branch, and then when it goes to this junction, and then part of the electric current will flow to this side. So these are the example of a series and parallel circuit.
Moving on, differentiating between series and parallel circuit. The series circuit, as you have seen earlier on, there is only one path for the current to flow in a closed circuit. As you can see here again, that in this series circuit, as the current is flowing, it is going in one direction and it goes through all of these components, the lamp, the resistance, the lamp again, resistance. It is going through it all without having to split the current up. As for parallel, as you can see, as it goes from this, if it moves in this direction, it would come to this point and the current would have to split into two components and go in these two directions. So that is the difference between, one of the differences between the two. Moreover, the current remains same for all the components of the circuit when in series. However, when in parallel, the current differs. For voltage, it is vice versa. The voltage is different across each component, whereas the voltage remains the same across each component in parallel. So that those are the two differences. Another thing is the total resistance. When finding the total resistance in series circuit, you can see that you will simply just add all the values of the resistance. If there are, say, 4 resistance connected in series, you will simply add the values you have for those 4 resistance and it will give you the total resistance. However, for parallel, you will be adding it in a fraction form and the value would come in the denominator, and in the end you would have to reciprocate it. For instance, the last value you get is 2 over 10. The total resistance you get 1 over RT is equal to 2 over 10. So if you reciprocate it, 10 would go on top and 2 would come at the bottom and you would have 5 ohms. We'll talk about this more in an example further on. Now, Ohm's law, this is another important component when studying about circuits. What is the Ohm's law? It is when current passes through a conductor from 2 points and it is directly proportional to the voltage across these 2 points. If you look at the formula, it is V is equal to IR. Now, another simple way in which we can remember this is by drawing up a triangle and having it split into 3 different parts, V, IR. So V is equal to I times R. Now, voltage, it's measured in volts. R, resistance, is measured in ohms, and the current is measured in amps. So A. Moreover, if you have a question whereby the voltage is given and current is given and we don't know the resistance, so looking at this triangle, R is equal to V divided by I. And if you're finding I, V divided by R. So that is how this triangle works. Moving on, some of the symbols that one would find important for this lesson, as well as many more to come. So I have outlined some of the important ones. So firstly, the resistance. This is the symbol for resistance. So this is how you would draw a resistor. It is basically a rectangle and then you have 2 wires on either sides. Voltmeter, it's simply a circle with V and again the wires on either side. Similarly for ammeter, and another important one is the galvanometer. The switch, battery, as you can see the difference in the two. This switch is called an open switch since you can see it is open here. It will be closed once this is connected to this. Battery, as you can see here, positive terminal, negative, positive, negative. Another thing which is important is the symbol for the capacitor. So these are some of the important ones that you would be using frequently. Moving on, talking about resistance. Now, what is resistance? There's a simple diagram which I have given. These are what resistors look like in real life. You can see in the diagram actually It's basically a rectangle, but this is how it looks like in real life. Now, it is an electrical quantity that measures how the device or material reduces the electric current flow through it. You can see the resistance and current go together. They have a connection. Now, resistance is measured in ohms, and this is how you write ohms. This is the symbol for ohms. Also, as I mentioned earlier, that resistance and current have a connection. So they are actually inversely proportional to each other. Inversely proportional means that if one value is high, the other value is low. So that's what it says here. The lower the resistance, the higher the current. So if, for instance, you have a resistance which has a very high value, then the current that passes through it will be very low, and vice versa. If the resistor has a low value, as mentioned here in the slide, it has a higher current passing through it. Alright, so example one. Our first example is on series circuit, and you have to find the total effective resistance of the circuit. Now, if you look at the diagram given there, the resistors are connected in series, and you simply have to add these two values to get your answer. That's the formula. RT is equal to R1 plus R2. Either one of these values can be R1 or R2. So you can have 2 plus 8 or 8 plus 2. It still gives you the same answer, which is 10 ohms. So that is the first example talking about series circuit.
So continuing from example 2, which is based on parallel circuit, we have to find the total resistance for two resistors as shown in figure 2, where our R1 is 40 ohms and our R2 is 10 ohms. So the general formula for finding the total resistance is 1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over Rn, as discussed in the notes. For this question, since there are only two resistors given, we can use 1 over RT equals to 1 over R1 plus 1 over R2. So our R1 is 40 ohms and our R2 is 10 ohms. We just need to insert the values in the formula, which will give us 1 over RT equals to 1 over R1 plus 1 over R2. Our R1 is 40, so it will be equals to 1 over 40. And our R2 is 10, so it will be equals to 1 over 10. So 1 over 40 plus 1 over 10, which is equals to 1 over RT equals to 1 over 8. So here we need to take the reciprocal on both sides to get the total resistance. So taking the reciprocal of 1 over 8, that will give us 8 over 1, which is equals to 8. So our total resistance for this question is 8 ohms. Now moving on to the student activity. The students will be divided into groups to answer the following question, and the groups will be divided into number of students of 4 or 5. That will depend on the number of students present in the class. For question 1, it's just similar to the example question where we need to find the total resistance in series circuit and in parallel circuit. And both part of this question is worth of 2 marks. 1 mark will be given for writing the correct formula, and the other 1 mark will be given for writing the correct working and getting the correct answer. So for question 1, part A, we need to find the total resistance in series circuit. So the formula for finding the resistance in series circuit is R total equals to R1 plus R2. And for question 1, part B, we need to find the total resistance in a parallel circuit. Now moving on to the solution of question 1. For question 1, part D, we were supposed to find the total resistance in series circuit. So by using the formula for finding the total resistance, so R equals to R1 plus R2, our R1 is 100 and our R2 is 50. So basically adding both, 100 plus 50, that will be equals to 150 as our total resistance. For question 1, part B, we were supposed to find the total resistance in a parallel circuit. So the formula for finding the total resistance in a parallel circuit is 1 over R2 equals to 1 over R1 plus 1 over R2. Our R1 is 100 and our R2 is 50, so that will give us 1 over 100 plus 1 over 50. Now we are left with 1 over RT equals to 3 over 100. So as I have said in the example question, in this step we have to take the reciprocal on both sides. So taking the reciprocal of 1 over RT, that will give us RT over 1. And taking the reciprocal of 3 over 100, that will be equals to 100 divided by 3, which will give us 33.33. So the total resistance for this question is 33.33 ohms. Now moving on to the question 2. The total voltage is given as 12 volts and we are supposed to find the current in series and in parallel circuit. So before finding the current, we can find the total resistance. So for question 2 part A, since it's based on series circuit, so if the total resistance for series circuit will be equals to R1 plus R2. Our R1 is 1000 and our R2 is 200, so basically adding both, 1000 plus 200 is 1200. So now we have found our total resistance. Now we have to just use the formula I equals to V over R. The voltage is given as 12 volts, so now we just have to insert the values in the formula. Our voltage is 12, so V is 12 and our resistance we found is 1200. So 12 divided by 1200 equals to 0.01. So our current is 0.01 amps. That's for question 2 part A. And for part B, we need to find the total resistance in parallel circuit first. So how are we going to find it? By just simply using the formula 1 over R1 plus 1 over R2. Our R1 is 200 and our R2 is 1000. So taking the reciprocal of that, we get the total resistance as 167 ohms. So now coming back to the formula, I equals to VR, we found our R as 167, so just have to insert it in the formula. Our voltage given is 12, so 12 divided by 167, our current comes to 0.072 amps. Now moving to the question 3, and for our question 3 and 4, the circuit diagrams are given and we are supposed to find the total resistance in series and in parallel circuit. So the first circuit diagram is based on parallel circuit, and the second question, which is question 4, that circuit diagram is based on series circuit. So moving on to the solutions for these two questions. For question 3, we were supposed to find the total resistance in a parallel circuit. So the formula for finding the total resistance in parallel circuit, 1 over RT equals to 1 over R1 plus 1 over R2. Our resistance 1 is 8 ohms and our resistance 2 is 2 ohms. So that's equals to 1 over 8 plus 1 over 2, which is equals to 10 over 16. Now taking the reciprocal on both sides, we get our total as 8 over 5 ohms. And moving on to the question 4, which is based on series circuit, our R1 is 2 and our R2 is 5 and our R3 is 6. So since it's a series circuit, we just basically add them all. So 2 plus 5 plus 6, which is equals to 13 ohms.
Moving on to the conclusion of our lesson today, students. First of all, we got electricity. Electricity is basically the flow of electrical power, or is a form of energy made up of charges that can produce light, heat, or motion. Light examples are bulbs at home, and heat examples which can be irons or microwaves, and motion examples are just basically electricity which is used to move something. moving on, looking at series circuit. As we discussed in series circuit, voltage divides. As we can see, there's a 3 volt cell, and voltage is divided accordingly to the 3 components available there. So the voltage divides in series circuits. And looking at current remains same in series circuit. So the 3 bulbs, as we can see right there, current remains same across these 3 bulbs. And looking at resistance adds up in series circuits, as we discussed before. Basically, we just add resistor 1 plus resistor 2 plus resistor 3 plus resistor 4 to give total resistance in a series circuit. So in a series circuit, voltage divides, current remains same, and resistance adds up. Now moving on, looking at a parallel circuit. In a parallel circuit, the voltage remains same. So the voltage across any components in a parallel circuit, it remains same. And current actually divides in a parallel circuit. And looking at resistance, this is how we add resistance in a parallel circuit. As discussed before, we add 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3 to give total resistance. And the total resistance is also 1 over total resistance. So in the final answer, we have to take reciprocal to get our total resistance. So in a parallel circuit, voltage remains same, current divides, and this is how we add resistance. We take 1 over R1 and 1 over R2 to find the total resistance. And the final thing which we learned today, which was Ohm's law. Ohm's law, which is defined as the current through a conductor between 2 points, is directly proportional to the voltage across the 2 points. Now, in simple terms, we can state Ohm's law in these simple diagrams. This is basically Ohm's law. So to find voltage, we multiply current times resistance. As you can see, current and resistance are here. Ignore this E, students. This E is supposed to be V right here. So yeah, that's how we can actually find the current and resistance and voltage. If you know this triangle, then remembering these formulas won't be hard for you. Now at this point, I would ask students questions if they have any questions or doubt regarding the lesson, and after having discussed and cleared doubts, or if none, then I would proceed on to randomly asking students questions related to the lesson. And these are some questions which I can ask students. For example, on Ohm's law, what is the formula of Ohm's law? And on resistance, I can ask them, can you name which type of circuit uses this formula to find the total resistance? So students can look at this formula and then decide in which circuit is this formula used. And then okay students, this is your homework activity. We have 2 questions, and question number 1, which is do the research on where parallel and series circuits are used in daily lifestyle. So you have to do research on this to get your answers, and I hope you all will attend these questions at home, and we are going to discuss we are going to mark these questions in our next lesson. So make sure to attend these 2 questions and be ready for our next lesson where we're going to mark these questions. Alright students, thank you all for attending our class today, and you can now start getting ready for your next class. Thank you very much.